Hello, everyone. My name is Aditya Gupta, and I'm with Arthur. And today we're going to be sharing you guys the results of a survey we conducted for the final project in this class. And we investigated the number of hours of sleep received by students in Ms. Ball's class. And we call our presentation Sleepless in Statistics, and that kind of hints towards some of the results we're going to be discussing today. But we're going to start off from the real basics here, and Arthur will get you started with that. So here we go.
So our investigative question was, do students in Miss Ball's AP Statistics class get less sleep than the national average for high schoolers on nights before an assessment?
All right. So in order to test this question, we devised this three-step plan. So it starts pretty simple. We're going to start by surveying a representative sample of students in our class and ask them how many hours of sleep they receive. Then for step 2, we're going to construct a 95% confidence interval so that we get like a sense for like what is the reasonable range of the true population mean number of hours of sleep received. And then finally, we're going to conduct a significance test to evaluate if students in our class do actually receive less hours of sleep than the national average.
So for our survey plan, we figured that the more the hours of sleep that students in Miss Ball's AP Statistics class obtain before an assessment, that could depend on what period they're in. For example, students with statistics later in the day might get more sleep because they're sleeping in. So accordingly, we conducted a stratified random sample, stratifying by class periods, and we sampled a total of 20 students to get a moderately large sample.
Okay, so in order to divvy up the number of students by period properly, we wanted to make sure that we did that in proportion to the number of people that are actually in each period. And each of Mrs. Ball's classes has a different size. So as we can see on the PowerPoint there. So we're going to make sure that we sample a representative proportion from each. So we conducted the calculation that you can see. We take the number of people in each period and divide it by the total number of people in all of our classes combined, and then just multiply by 20 for all periods. And so we get 7 students from both periods 4 and 7, but just 6 from period 3.
To ensure proper random sampling, this is what we did. We got a list of students in each class using Canvas Inbox. We then organized them in alphabetical order, and then using a random number generator, we found the numbers of students who were selected. So we would just generate a number from 1 to the total class size, which would be 24, 28, or 30. And then we picked that person, and then we generated until we had enough numbers for all the students that we needed to sample from that period.
All right. So once we determined the precise students that were going to be in our sample, we then had to actually go ahead and conduct the sample. So in order to do that, we need to survey them. So what we did in our surveys, we asked them 3 questions, just like their name, their class period, and then the question for how many hours of sleep did you attain on average before an assessment. So the first 2 questions are mainly just there for the purposes of just verifying their identity and making sure we don't get like duplicates or something. While the third one is, that's the real question that we did analysis on.
And so you can see the 20 data points that we got from our survey, and we found that the mean was 6.45 hours, and the standard deviation was 1.234 hours.
Okay, so now that we had the data, we could move on to phase 2 of our analysis, which is actually conducting the constructing the confidence interval and conducting the significance test. So in order to do that, we need to make sure that we're checking our conditions. So there's a few conditions to be checked here: random, 10%, large counts, and normality, and we're going to talk about each of them in turn over the next few slides.
So for the random condition, the data in the survey did come from a randomized sampling method, and we did use stratified random sampling to limit confounding within class periods. So I think the random condition was met pretty well.
All right. And then we had the 10% condition. So for the 10% condition, we note that there's a total of 82 students in all of Ms. Ball's AP Statistics classes, but we did sample 20 students, which is about 24% of the entire population. So technically speaking, this condition is not satisfied. However, we can address this problem by noting the following assumption, the following observation, that in general, when we're sampling without replacement, which is what the 10% condition is all about, the standard deviation of a sampling distribution of a variable is generally less than in comparison to when we're sampling with replacement. So the result is that you can conduct some mathematical analysis, but how you can account for this is by multiplying the standard deviation and accordingly the standard error that we get from the survey as well by the following coefficient: square root of n which minus n over n, well, capital N minus little n over capital N minus 1, where capital N is the population size and little n is the sample size. The reason this formula makes sense is because, for instance, if you think about it, if we're sampling everyone in the population, which would mean that little n is equal to big N, then this coefficient would equal to 0. And that makes sense because if you sample everyone in the population every time, then the sampling standard deviation of the sampling distribution, that would just be 0 because you're going to get the same result every time. So the formula does make sense. And yeah, we're going to continue using that going forward.
So for the large counts and normality condition, the sample size of 20 is less than the required 30 to apply the central limit theorem. However, the histogram data shows no strong skew or outliers, so we can say that this condition is met, and as long as we proceed with caution.
Okay, so now that all our conditions are met, we can actually move on to constructing the confidence interval. So what we're going to be doing is we're going to construct a one sample t interval for the population mean, and we're going to use the standard 95% confidence level. So our degrees of freedom would be 20 minus 1 or 19. And then we can get our formula for the confidence interval using that equation down there, which is just a standard one, just with the factor of the population correction coefficient included in there. And then we can find the value of t star that we need using that inverse t calculator command. And when we do that, we get about 2.093.
And we substitute the values into the formula for a confidence interval. We get 6.45 plus or minus 2.093 times 1.234 over times square root of 82 minus 20 over 20 over 81, and that will simplify to the interval of 5.945 hours to 6.955 hours. So therefore, we can say that we are 95% confident that that interval captures the true population mean of numbers of hours of sleep obtained by students in Ms. Ball's AP Statistics class before an assessment in her class.
Brilliant. So now that we've conducted our confidence interval, we can get kind of a sense for what our significance test will yield as a result, but we want to make sure that we perform it properly. So for the significance test, we aim to evaluate the following hypothesis. We want to check the null hypothesis that mu equals 7 against the alternative hypothesis mu is less than 7. So in this case, mu represents the true population average numbers of hours of sleep obtained by students in Ms. Ball's AP Statistics class before a test. And the reason we're testing at mu equals 7 is because 7 is the national average numbers of hours of sleep obtained by high school students. So we've checked our conditions again, which are the same for the confidence interval as for the significance test. So we're just going to proceed with a one sample t-test here and use df degrees of freedom equals 19 again, and we'll use alpha equals 0.05 as the standard value. And then we can just find a test statistic using the standard formula, statistic minus parameter over standard error.
So using the formula for standard error that we've already discussed and plugging in our numbers, we get that the standard error is equal to 2.41 hours. And then substituting that into the formula for a test statistic, we get that t equals 6.45 minus 7 all over 0.241, and that gives us t equals negative 2.282.
All right, so then we just can finish off the test by finding the p-value. So when we do that, we need to find p, the probability that the test statistic would be less than negative 2.282 because we're doing a one-sided t-test. And we use the appropriate calculator command with the tcdf and get p is approximately 0.0171. and you can see that the t-curve here shows the appropriate shaded area. So as our p-value of about 0.0171 is less than alpha equals 0.05, we can reject the null hypothesis, and thus we do have convincing statistical evidence that students in Ms. Ball's AP Statistics class receive fewer hours of sleep than the national average of 7 hours before an exam.
As a way to sort of conclude, as previously established, there is evidence for a difference between the national average numbers of hours of sleep for high schoolers and that which is received by Ms. Ball students before a statistics exam. However, since we used a sample survey for this investigation, we don't have evidence to suggest any form of causation. In other words, it doesn't follow from our study that the presence of the exam in Ms. Ball's class on the next day is the factor that causes students to obtain fewer hours of sleep the night before. And we also don't have any proof that it's Ms. Ball's fault at all. Thus, future AP Statistics students should conduct experiments to verify if there's causation involved between the presence of an exam in Ms. Ball's AP Statistics class or any other factors they believe could be producing this result, and the number of hours of sleep received by students on the night before the exam.
All right, thank you everyone for listening to our presentation. We hope you have a great day. See you later.